Press the button and we start the recording.
I pressed the button and I started to record. Everybody,
Milks.
Monica. Last lesson in periodic table.
Yes, it is. And possibly the most important one.
Periodic trends. So we got to describe these trends, radius, reactivity, ionization, energy, electronegativity, in both periods as we go across and groups as we go down.
Correct.
And relate them
to these big bad words that we need to learn what they mean.
Exactly. I'm going to want to relate them to nuclear shielding, of course.
Well, actually, we can use nuclear shielding to explain every one of these particular things if you got your shielding definition and principles down.
Effective nuclear charge.
Yes. All right, trend number one. Atomic radius
of the element.
Before we start, disclaimer, ready? The why you need to know. The actual trend you do not need to memorize. You can look it up in table S. You can pick one element, pick another element, go to table S, look them up, look up their atomic radiuses and say, oh, the atomic radius goes down as I go across the group, or it goes up as I go down. But here's the issue. The why is where the bang for the buck is. So you don't get full points if you don't know the why. That's what we're here for.
Mm-hmm.
How that?
So as you go right to left across the period, so becoming more and more non-metallic, the atoms get smaller.
Which defies logic because I'm adding stuff.
Both protons, neutrons, and electrons. I'm adding all three things, but we know the atoms get smaller.
And the picture shows it. Mm-hmm. It's actually been verified, right?
And yes, proven. Facts.
And now the why.
Hang on. I think it should be left to right there.
Oh. Yeah.
You don't usually edit these things.
They're right.
Check out the image instead.
Can't we just fix this over?
No, we shall not fix it and start over. We will continue.
Or he smashed the screen. Smashed the button and the video stops. The reason this is because the effective nuclear charge is increasing. I am getting more protons and I'm not adding any interference. So more protons, pull stronger. Pull more, shrink.
Mm-hmm.
That's really
you feeling me, bruh?
Yeah,
bruh. And they get closer and closer.
Right?
The valence shell and the nucleus, that is. And that's how we measure the radius. So there's your trend.
There it is. Now, as I go down, something different.
Yes.
Okay? So as I go down, I am adding shells. So what happens?
Getting bigger and bigger.
Right. And why?
So we've got more energy levels.
Yes.
I was going to go for protons first.
Also true.
Yes.
Also true.
I am not super great with the...
It's okay.
Get it.
So
it took me a long time to get this. It's all right. So as we add more protons, neutrons, and electrons as we go down a group, we're not only adding those electrons to the valence shell, we're actually adding entirely new shells to the atom. So period 1, group 1, 1 shell. Period 1, group 2, 2 shells. Period 1, group 3, 3 shells.
So what we're saying is just because I'm adding more protons doesn't mean the nucleus is doing a better job, because now there's more interference. So even though I have more positive magnets in the middle, I have all this interference between the nucleus and the outside electrons. And so, can you feel me, brah? No, bro. See? So I get bigger. Plus, I'm just adding stuff. So it just makes sense. If I put on more layers of clothes, I get wider.
Mm-hmm.
So that one honestly makes sense from that perspective.
Electronegativity of the elements.
Can we define electronegativity one more time?
This is the electron, the atoms pull for somebody else's electrons. I like those electrons you have there. May I have one perhaps, sir?
Yeah. So in other words, how thirsty are you? Are you thirsty for electrons or not? Does that make sense?
Exactly. And it's related, guess what, to effective nuclear charge, of course. Electronegativity values increase from left to right across a period because you feeling me, bro? That shout goes so far, it goes to the next atom beyond the valence shell, and that other atom's like, yo, somebody wants electrons. I'm feeling them, you know?
Seriously, and if you think about it, we all want 8. So if I have 1 or 2 valence electrons, I want to go ahead and lose, because losing 2 is easier than gaining 6.
Right.
But when I get towards the other side, I got 7. I'm getting thirsty. I want that 8 real bad. How
Right.
bad do I want 1? Well, I got 7. I really want 1.
So
I
I'm
will
gonna
fight
take
you
it.
over it.
Exactly. So your electronegativity value would be much larger.
And that we've kind of
Effectively,
gone over
nuclear
why.
charge increases, and the bigger it is, the stronger charge. It's so strong, it doesn't only pull on its own valence electrons, it pulls on everybody else's too.
That's right. As I go down.
Top to bottom. You want to try this trend?
Sure, the
Yeah, right.
Electronegativity decreases. So that's because the effective nuclear charge is decreasing down the group. So the nucleus has a positive charge, and it is unable to pull on the electrons from the other elements.
Very well, because all those kernel shielding electrons, the shout for "you feel me, bro" gets lost in all the commotion, and electrons from other atoms are just like, somebody say something. What? No?
Did you hear something?
No.
Just Monica.
Just
Trend number 3, ionization energy. Ionization energy is the energy needed to remove the outermost electron. So once we get that definition straight, we can apply it.
It's how much energy it actually takes for me to take them electrons.
Right. And so we can make some analogies here. So first, as I go from left to right across the period, the ionization energies increase.
Correct.
Right? Because right, all of a sudden I have 6, so I don't want to lose. So the energy
Right.
needed to take a lot.
Mhm.
So the effective nuclear charge is increasing. I'm not increasing energy levels, but I'm increasing the number of protons, increasing that pull, if you will.
Exactly. As you go down a group, ionization energy drops for the same reasons that we keep saying.
Yes.
The effective nuclear charge is decreasing as you go down. So the
Right.
electrons on the outer shell and other electrons do not feel the pull of the nucleus as strongly, which makes them loosely held and very easy to get stolen away or knocked off by some other element.
I can't help but use a football analogy with this. Ready?
High and tight.
Tiki Barber used to hold the ball high and tight. How much energy does it take for you to get him to fumble versus Mike Vick when he came into the league and held him way out here? Hold the ball out here. How much energy does it take for you to get me to drop the ball? Not a lot, just a little bit of this, right? So it kind of makes sense that the farther away that valence electron is, the easier it is for somebody to come by and grab them. Because that whole, "Are you feeling me, bro?" Not
No.
so much.
Not at all.
So somebody else, I'm going to go with him.
Give me that electron.
See?
Pump.
He got him.
High electronegativity, low ionization energy. Give me that.
See, we almost done. You're good at that.
You can
You're
take
good
it.
at that. Go take over.
We're talking about ion formation and radius changes. So for the metallic elements, they have low ionization energy and electronegativity because their Z effectives are small. They're going to lose their valence electrons to
Metals are losers.
ions.
Yep.
And for losing an electron, they're going to have that negative. They're going to lose that negatively charged particle, and the net charge is going to be positive. The ion is smaller because it's losing those electrons,
Right.
losing a whole shell.
And non-metallic elements is the opposite.
Correct.
These have very high ionization energies and electronegativities due to having very large effective nuclear charges. And therefore, they're prone to stealing or gaining valence electrons from other atoms and forming ions that way. Since they're gaining an electron, it means they're picking up a negatively charged particle from somewhere, which puts the balance of protons and electrons out and in favor of the electron. So nonmetals form negative ions, and when you're soaking up, pardon me, electrons from somewhere else, you're adding them to the valence shell. All the other ones spread out a little bit to accommodate them, and the ions get larger. So metals get smaller when they lose their electrons. Nonmetals get larger when they gain up somebody's electrons.
That sounds like a good way to remember it. And I think that we might be.
Hey,
real
third
quick
unit
review.
in the books.
Yeah, done. Quick review. Ready? Gain an electron, I become negative. Lose an electron, I become positive. We need to not mess that up all year. Get that straight.
Otherwise, it's curtains for you.
Bye, everybody.
Push the button.
Push the button.
And then it turns.